All right, on today's episode of Python Papi, we're back inside our TensorFlow course, and we're still doing our malaria precision, recall, and accuracy module. Let's have a look at what we went over today. Yesterday, if you recall, we went over the confusion matrix, and today we're going to pick up where we left off. So, based on what we've seen so far, we're going to introduce several new performance metrics, and all of these use different formulas. So, for the precision, we have the true positive divided by true positive plus false positive. For the recall, we have the true positive divided by the true positive plus the false negative. For accuracy, we have the true negative plus the true positive divided by the true negative plus the true positive plus the false negative plus the false positive. And for the F1 score here, we have two times the what was the POAK? Two times the positive, or two times the precision times the recall divided by the precision plus the recall. And specificity, we have the true negative divided by the true negative plus the false positive. And we're just going to explain that right here underneath. So for the first one, we have the precision, which is the number of the true positives divided by the number of true positives plus the number of false positives. For the recall, we have true positives divided by the number of true positives plus the false negatives, and so on and so forth. It's the same thing we just explained. I just wrote it out here. Now, we're only going to examine the first three at first. So, what do we notice? We'll notice that in the precision and recall, we have the true positive, and true positive, and true positive. So, let me show you that. So, you can see here we have the true positive and true positive in both the numerator and denominator. In the precision, and then in the recall, we have the true positive in the numerator and denominator as well. What differentiates them is the fact that in the precision we have a false positive in the denominator, and in the recall we have a false negative in the denominator. So let me show you that. That's what makes them different. So you can see for the precision we have a false positive that gets added to the true positive, and then in the recall we have a false negative that gets added to the true positive. That's what makes those two, the precision and recall, different. So this means that if we have a high number of false negatives, that's when we have a constant. For example, this means that if the number of false negatives is high, that's when we have a constant. For example, a constant k divided by a high value. So we would have something like this: k divided by high. Now this will give us a low output. So we want to have a low recall, then we need to have a high value or high number of false negatives. And if we want to have a low precision, then we need to have a high number of false positives. In our case, we're trying to minimize the number of false negatives. And since we're trying to minimize the number of false negatives, it means that we're trying to maximize the recall. So that's what I'm going to do for right now. That's all the reading I'm going to do. We did dive a little bit deeper, take a lot more notes, and do a little more graphing. As you can see, we did get to our ROC plot here. But I'm not going to go over that today. We will pick it up tomorrow. I will keep you posted every step of the way. But for now, it's the Python Papi. You guys stay Gucci.